Welcome to GES Digital Intervention Program for Senior High Schools. This is Mathematics Lesson 4 on Algebra. And today, we shall be factorizing expressions involving difference of two squares. I am your facilitator, Nala Debu. Let's take a little teaser to warm up the brains. If 3 foxes can catch 3 rabbits in 3 minutes, how long will it take 100 foxes to catch 100 rabbits? Discuss this with your friend in 1 minute. I know a number of answers are coming to mind, but well, the answer is 3 minutes. I don't have to explain that. You know how to get the answer. Today, we'll be learning how to factorize algebraic expressions involving difference of two squares. And there are some keywords that will come up. As usual, we have difference and we have squares. We'll start this lesson by first looking at the exercise on your screen. Evaluate the following. 1. 49 minus 25. 2. 81 squared minus 71 squared. 3. 115.5 squared minus 15.5 squared. 4. 79 squared minus 69 squared. And finally, a squared minus b squared. I'll give you 3 minutes for that. Good. I know you have the answers. And I also know you have gone through different ways to get these answers. Can we compare this to my solution? Let's say the first one. 49 minus 25. I can write 49 as 7 times 7 and 25 as 5 times 5. That gives me 7 squared minus 5 squared. And to do that, I first take 7 minus 5 times 7 plus 5. And when I do, I will get 2 times 12. That is 24. This is stretch free, isn't it? And I know that was what you also got. Now for the number 2, it was 81 squared minus 71 squared. And I'm going to go by the same method. So I have 81 minus 71 times 81 plus 71. It's easy for me to add and subtract 81 and 71. 81 minus 71 gives me 10, and 81 plus 71 gives me 152. So multiplying 10 by 152 gives me 1520. Stress-free. And if you take the number 3, it's the same process. 115.5 minus 15.5 times 115.5 plus 15.5. And of course, we have 100 times 131. And this gives me 13,100 as my answer. For number 4, we follow the same process. So I'll have 79 minus 69 times 79 plus 69. And finally, I have 1,480. Now, what about a squared minus b squared? This brings us to our lesson for today. Difference of two squares. Simple means subtracting two squares. A square is any term or any number that has an exponent of 2. And so, if I have a squared minus b squared, from the exercise we just did, you can see that I can write it easily as a minus b times a plus b. And that is the factorized form of a squared minus b squared. To help us consolidate this learning, we are now going to look at some examples and see how we can apply this knowledge to it. Let's take some examples. Factorize the following. 1. 81d squared minus 36h squared. 2. R minus 5 all squared minus 1. And 3. 2x plus 5 all squared minus 8 minus 3x all squared. I know you can apply the same principle to factorize this. Try it with your friend for just 3 minutes and let's see. Now let's compare your answers to mine. Number 1, 81d squared minus 36h squared. I will need to express the 81 and the 36 as squares. And of course, 81 is 9 squared and 36 is 6 squared. So I can write them as 9d all squared minus 6h all squared. This gives me difference of 2 squares. And applying the same principle, I'll now have 9d minus 6h times 9d plus 6h. And I'm there. Let's take the second example. R minus 5 all squared minus 1. 1 is a number that can take any exponent, and it will still remain the same. So as long as r minus 5 is squared, I can also square the 1, and I'll get the same as 1. So I have r minus 5 squared minus 1 squared. And applying the principle, I now have r minus 5 minus 1 times r minus 5 plus 1. And simplifying the brackets, I'll have r minus 6 times r minus 5. And this is the application. Finally, question 3. 2x plus 5 squared minus 8 minus 3x all squared. Since both terms are squared, I just apply the principle. I will now have 2x plus 5 minus 8 minus 3x. But remember, the minus 8 minus 3x, the 8 minus 3x should still be in the brackets, so that when you are expanding, the negative would be used very well. So I have 2x plus 5 minus 8 minus 3x times 2x plus 5 plus 8 minus 3x. And expanding the brackets, I'll have 2x plus 5 minus 8 plus 3x and 2x plus 5 plus 8 minus 3x. Now simplifying each bracket gives us 5x minus 3 times 13 minus x. Now let's look at how this difference of 2 squares is applied, most especially in exam questions. Let's take an example. Example 1. Factorize m squared minus 2mn plus n squared minus r completely. Now, if you look at this, you realize that if you take the first 2 terms, there is the highest common factor. But if you take the last 2 terms, there is no common factor. And if you factorize the first 2 terms out, you will not get the last 2 terms. So this calls to mind other alternatives. We can consider the first 3 terms and try to see what is it. And if you look at the first 3 terms, you realize that it is a square. And what is that square? The first 3 terms is the square of m minus 2. So it means we have to write the r also as a square. Any number can take a square. All I need to do is I square root it, then I square it. the square of a square root still gives you the number. I can now write my expression as m minus n all squared minus square root of r all squared. And this is a difference of two squares. Applying the principle, I'll have m minus n minus square root of r times m minus n plus square root of r. Let's take another example. You have simplify 12x squared minus 27g squared all over 2x minus 3g. Here you can see that 12 is not a perfect square, and neither is 27. So what do we do? But we can also see that 12 and 27 has a common factor. And what is that common factor? That common factor is 3. So I'll factorize 3 out. And when I factorize 3 out, I'll now have 4x squared minus 9g squared. And now I can express 4 as a square and 9 as a square. This now gives me 3 times 2x squared minus 3g all squared. And so I'll apply the principle, and now I'll have 3 times 2x minus 3g times 2x plus 3g all over 2x minus 3g. But what can we see? The 2x minus 3g can divide 2x minus 3g as the denominator. And so when I divide that, I'll now have 3 times 2x plus 3g as my answer. Let's take yet another one. Say factorize 64 minus 9a squared b squared. So here again, I can see that I can express 64 as a square of a number and 9 equally as a square of another number. So 64 is 8 squared and 9 is 3 squared. I can now write this as 8 squared minus 3ab all squared. And applying the principle of difference of 2 squares, I'll have 8 minus 3ab times 8 plus 3ab. Isn't that wonderful? Let's take another question. It says y squared minus 4ay plus 4a squared minus m. It says factorize y squared minus 4ay plus 4a squared minus m completely. And to do this, again, y squared minus 4ay plus 4a squared is a square. And that is the square of y minus 2a. And m can also be written as a square. So I write it as square root of m all squared. Now applying the principle, I'll have y minus 2a minus root of m times y minus 2a plus root of m. And this is the factorized form. So, with this knowledge, you can also try the following questions. Try them at home, try with your friends. 1. Factorize 5d plus 7 all squared minus 1 minus 5d all squared. Then 2. 4p squared minus 12pq plus 9q squared minus t. Do this exercise with your friends and look for more of such exercises from other books to complement your learning. Today, I know we have learned something. We have just looked at how to factorize expressions involving difference of two squares. And I know you have seen that the principle is very easy to follow. I'll see you again in our next lesson. Thank you and bye-bye.